Welcome to this explainer. Okay, today we're not just talking about keeping a couple of goldfish in a bowl on your desk. Oh no, we're diving into the absolute high stakes engineering required to safely park a massive water filled ecosystem smack in the middle of your living room. Seriously, designing an aquarium of this magnitude? It's a huge project. It's a wild blend of carpentry, plumbing, electrical planning, and honestly, above all else, pressure tested safety. To really wrap your head around the sheer scale of this, you gotta realize that once it's filled up with water, rock, and all the gear, this aquatic ecosystem is going to weigh well over 2,000 pounds. 2,000 pounds! Put that into perspective. You are essentially parking the weight of a small car directly onto your home's floorboards. Crazy, right? And that incredible weight brings us to a kind of terrifying reality, perfectly captured right here. Because the tank's weight and complexity can't just be fixed later. Meticulous sequential planning isn't just, a good idea here. It's literally your ultimate disaster prevention strategy. Think about it. You can't exactly just lift up a fully stocked 2,000-pound tank to fix a badly routed wire or a wobbly stand. So to avoid those catastrophic mistakes, we are going to follow a very deliberate sequence today. We'll start with planning for massive weight, then move to foundation and perfect leveling. After that, it's plumbing, sealing, and testing, followed by establishing the biological cycle, and finally, logistics for long-term success. All right, let's jump right into phase one, planning for massive weight. This is all that crucial pre-build prep that has to happen way before a single piece of wood is cut or any gear is even purchased. So, before you do anything else, you absolutely must map out a few things. You need to confirm the display footprint, figure out your ideal viewing height, and map out exactly how those utilities are going to run. But the biggest thing, you have to map out service access. Just imagine trying to do a quick water change or swap out a filter without leaving enough room for yourself to actually maneuver. Trust me, awkward, heavy disassembly later on is a nightmare you definitely want to avoid. Which brings up a massive question. Where is that 2,000 pounds going to sit relative to your floors, doorways, and wall studs? You really have to meticulously plan exactly where this immense weight is going. You're integrating a massive structure into your existing architecture, and if you don't align it perfectly with your floor joists and load-bearing walls, well, your house simply won't be able to handle the load safely. Moving right along to section 2, foundation and perfect leveling. We're talking about the ultimate skeleton of your build here. Now, the stand is the absolute foundation of this entire project. Heavy-duty framing and precise leveling with shims, totally mandatory. Why? Because even tiny, microscopic unevenness can heavily stress the tank over time. Glass and acrylic just do not bend favorably when they're under thousands of pounds of pressure. Seriously, if the stand is off by even a fraction of an inch, that stress compounds, and it can lead to catastrophic leaks down the road. So, this is your make or break moment. Verifying your stand is literally the difference between a setup that lasts decades and one that has a sudden, mysterious failure at 2 a.m. You need absolutely zero wobble at your load points. You have to level the top surface in multiple directions, and once that tank is actually on the stand, verifying that it sits perfectly flat and is fully supported along the bottom is just non-negotiable. Okay, with the bones perfectly set, we're moving into section 3, plumbing, sealing, and testing. This is where we actually start routing the veins of the whole system. If you're building a large display, you're going to rely on something called a sump. Basically, think of a sump as a secondary filtration tank used to increase your total water volume and thankfully hide all that bulky equipment. But using one means you need carefully routed overflow lines dropping down from the display and return lines pushing the water back up. Builders really have to route this plumbing intelligently to minimize unnecessary bends and make sure all those valves are actually accessible for troubleshooting later. Now, there is a huge difference between a dry fit test run and your final assembly. Keeping your plumbing dry fit for as long as safely possible is just a great best practice. It reveals any cabinet or sump clearance issues way before the glue actually sets. But when you move to final assembly, precision is absolutely everything. You have to align those seals carefully. Over-tightening the hardware is a classic rookie mistake, and it will easily crack your bulkheads and ruin the entire setup. And while you're routing all these lines, smart builders always include a few crucial protection features. Things like union fittings, those are a lifesaver because they mean you can easily disconnect hoses later without having to literally saw through pipes. You also need check valves for back siphon control and siphon break strategies on your return lines.
These features actively protect your expensive gear and, frankly, your flooring by stopping water from back siphoning if you suddenly lose power during a big thunderstorm.
All right, after everything is glued and set, we hit the leak readiness sequence. This is pretty much the climax of the physical build. You start with a highly controlled, slow filling process. As the water rises, you're constantly checking every single seam, bulkhead, and joint. Catching small drips right now, before the system has a full charge, is so crucial. Slowing down to catch a tiny pin drop leak is literally the only thing standing between you and a 200-gallon living room flood when the whole thing is fully pressurized.
Okay. Once the hardware is fully stress tested, we enter Section 4, establishing the biological cycle. We are officially shifting gears from mechanics over to biology. So, you've done the hard labor. The plumbing is perfectly sealed, the pumps are humming away, and the water is finally flowing. It naturally makes you wonder, is the build complete once the water is in? The emphatic answer to that is no. The build is absolutely not complete just because the water is in. It's really only complete when the biological cycle is fully established. You have to run the filtration continuously and really fight the urge to rush your livestock stocking decisions. You've got to wait until that biological ecosystem completely stabilizes so it can actually handle the waste load. And to reduce risk during this waiting or cycling phase, experienced builders use this time for full fill verifications. You're constantly checking, are the water flow paths accurate? Are the sump levels correct under normal operation? Are your GFCI electrical safety protections actually working with cords routed safely away from splashes? And above all, you verify the stand stability under full load now that thousands of pounds of water weight are fully bearing down. Which brings us to our fifth and final section, logistics for long-term success. Let's talk about living with this thing day in and day out. Because this is a massive long-term system, you have to be able to service it without disturbing the layout. That logistics piece has to be baked in from day one. You need to know exactly how water changes, hose connections, and filter media swaps are going to happen. The goal is to perform all that upkeep without moving heavy, wet, awkward components around. Let's face it, if maintenance is a miserable chore, you just won't do it, and the entire ecosystem is going to suffer. So finally, you establish your holy grail, the consistency routine. This means regularly inspecting plumbing connections, cleaning out intake screens, checking your overflow performance, and closely monitoring key water parameters. Following this strict routine is the single biggest determinant of system stability, especially during those highly volatile first few months right after the build. Going through this explainer, you can really see that building a massive display tank is an absolute masterclass in patience, precise engineering, and extreme risk mitigation. It's a beautiful, living piece of art, sure, but it demands utter respect. Which leaves us with one final thought for you. If you were to take on a massive project like this, when the pressure is truly on, will your foundation hold up?